Today we'll practice a few problems to decide if a reaction is SN1, SN2, E1, or E2. And there's actually a simple algorithm to use. Anytime you have SN2, remember to invert the stereogenic center, and only the stereogenic center that is bearing the leaving group. Otherwise, don't just invert whatever you see. That would be wrong. And if you have an SN1, make sure to draw a racemic mixture. Okay, so anytime you have an alkyl halide that is primary, the major is going to be SN2. If your alkyl halide is tertiary, the major is SN1. And of course, SN1 and E1 always comes together, but usually the major product is SN1, except if there is heat, then heat will make E1 have priority over SN1. Okay, so sometimes problems, they will give you an SN2 problem and then ask heat, and then you think, oh, that must be E2 because it's heat. No, so increasing temperature will favor E1 over SN1. So it's only when there's a competition between SN1 and E1, then increasing temperature will make E1 the primary, the major product over SN1. Otherwise, room temperature, there is a competition between these two, but SN1 will still have the major product. And anytime you have a strong base, you will have an E2 product, strong base E2 product. Even if it's a tertiary alkyl halide, strong base means E2 product. Okay, so strong bases usually have this form. It's an R with an O minus, or there's a bulky base like tert-butoxide. So if you see any strong base, bulky base, E2. And if it's an alkyl halide as secondary, and you are reacting it with something non-basic, or something that's a halide or a weak base like Cn minus, that would be SN2 major. Okay, and on the other hand, if your conditions is just a solvent, there's no negative thing whatsoever, it's going to be the SN1 E1 mixture. So remember, this is just a strong bulky base, looks like this, and this is just something that has a negative charge, while this just has no charge at all. All right, let's try the problems. Here we can tell that there is already a base, a strong base, good base, because it has a negative charge, and it's an RO, so that's a strong base. So we can tell already that's an E2 reaction. So we are going to draw an alkene on the most substituted carbon, and there you go. Sometimes they'll throw in the temperature, but just ignore it unless you're talking about a competition between E1 or SN1. So once again, temperature, if it's not SN1 or E1, we can just ignore it. But here, this is a negative. It's not a strong base because it's not RO minus. So this is going to be just an SN2 reaction. Therefore, you must draw it with an inversion of configuration. So such that, see, we don't invert this because it's not part of a reaction. But the chloride will be replaced by the iodide that is going to point down. So that is your inversion. Whereas if it were on a dash, you would put it on a wedge, etc. Oh, also, just a quick break here. Remember, only invert what's relevant. If you put it through SN2, you're only going to invert the leaving group's carbon. You do not invert the thing that's not affected. And also, let's just say you have a reaction and you're like, wait a second, there are two possible nucleophiles that can replace a leaving group. So which nucleophile do we use? So you will look at the pKa in that case. So iodide is a conjugate of a strong acid, so it has a very low pKa, whereas nitrile is an alkyne, so it has a pKa of 25. The more basic it is, the better the nucleophile. So this is going to be what will react with the substrate to form the new product. So on the other hand, here we have a negative charge that is not a strong base, so this is SN2. And you might think, wait a second, this is protic. Just remember, protic SN2 can still happen, just happens really slowly. So then SN2, we gotta draw the inversion of configuration. So now this will be up. Last problem, there is a strong base. It's negative, so yeah, but it's a strong base, so that is going to give us an E2 major. So we will draw an alkene somewhere, put it on the more substituted carbon, just on this side here. So there you have it. It's kind of straightforward.